My name is Thiemo. I have the pleasure to present a project that's called Don't Hack My Body. Yeah, so it's as you know, the fears we ended with. Here's a whole list of people that have been active in this project, or that are actually currently active. So it's a lot, not only my work, there's a lot of people that are working in this project. One of the things I like about this project is that its name is really, really cool. And it's so cool that actually Dagens Nyheter found this project and wrote an article. This was in last summer. They wrote a whole article on this project, a full page. So we were, of course, very happy about this. And if you do look at the title, you can see that there's some play with words that you will soon understand. So the motivation for this project is there are a lot of people who have implanted devices inside the body, and we believe that the number of implants that people will have in their bodies will just increase. Because people are getting older, they will have multiple diseases, there will be also more and more advanced hardware. Right, there will be drug delivery system, there will be artificial organs. Another thing is intracranial pressure monitoring devices that measure the pressure in your head. Mine is maybe pretty high since I'm talking here. And it does really make sense to network these devices, which I will tell you soon. But before you want to network these devices, you of course need to know how can you actually network them. There do exist some existing technologies for this, but they have some problems. In particular, for many of these technologies, the data rate is quite low. So what we have explored in Uppsala is that we're using typical RF radio frequency communication, like Bluetooth or Wi-Fi, inside the body. This does not work everywhere, but it turns out that within the fat layer in the body, within the fat, it works actually pretty well. One of the advantages is that fat is actually everywhere in the body. It turns out it works better for people who have more fat than for others, but yeah, but it works. And why you want to network them is that some places inside the body, it's actually quite hard to get signals in and out. And this is because of the layered tissues that we have around some of the organs, for example. But you could actually network them and then try to communicate from one sensor that is very deeply embedded to another sensor, and then to a sensor that is, and then to a like so-called aggregator node that is placed where it's easy to get the signals in and out. So this is why it makes actually sense to network these devices inside your body. Of course, if you want to start connecting sensors in your body, or if you start doing it, then security is really important, right? You don't want to have an attacker that takes over a device inside your body, right? In the worst case, this could be life-threatening for you if somebody messes around with your pacemaker, for example. Somebody could also install ransomware, like they did in, for example, Consum, but inside your body, you know, you would maybe think of paying, right? Also, the data we can collect from our body, this is really very private, so we don't want to leak it. In the future, we also expect that we may have some secure control loops inside our body, where you have, for example, a sensor measuring something, and you have an actuator that, for example, delivers a drug somewhere else in your body. However, security in the body is very challenging, right? We've heard in previous talks that IoT security is very challenging, but if you bring it inside your body, it becomes even harder because you have space constraints, which also means that you have power constraints. And we're also dealing with a new channel for communication here. And as I will say later, we cannot use this channel only for communication. We can also use it for sensing. And there are also some scenarios where you then want to provide access, right? If there's a medical issue, an emergency scenario, then you actually do want to provide access to the sensors inside your body. So this leads us to the objective of the project. We want to secure in-body sensor networks that are based on the communication through the fat layer within the body. For this, we have collected groups from Uppsala University. It's a group that I lead, a group that Christian leads. You've seen him before here. It's also a group with Robin Augustin who is one of the who works on the microwaves in medical engineering. It's also the group of, you have also seen Supra Kanti, he's sitting here, and Andre is also involved, may also be sitting somewhere here. And we also have people from the medical side. So we also have a person who works with plastic and reconstructive surgery, who is kind of our medical expertise in this project. The goals are, as I said, to secure in-body sensor networks and secure this new channel that we have for communication and for sensing. We also want to secure in-body control loops, and we want to make the security from within the body towards the external world. We have a set of demonstrators. These are so-called phantoms that emulate kind of the real tissue within the body. We have also started a little bit to do actually some experiments with real human tissues, but it was a long way to get there. So some of the results, I will present some of the overview here. We have a security architecture where we focus on how to generate the keys from entropy that we find within the body. That's a novel protocol that we have built there, and we're currently implementing it. And we have also extended it from previously just having it as a multi-hop, just as a single hop to multi-hop, where we have distances between several sensors. We're also working on antennas that restrict the leakage, right? You don't want the signals from inside your body to get out, and with antenna design, you can prevent this. We're working with very low power communication called backscatter communication that uses this fat intra-body communication. We're also working with privacy, as I said. One thing is to use antennas. The other one is to, try to avoid this by confusing attackers what you're actually sending, which I will talk a little bit more about this later. And we're working on covert communication, where you want to hide that there's actually some communication going on. Another area is secure in-body control loops. There we have focused on models for glucose and insulin dynamics, and in particular, when somebody is, eating something, this then can control this. This one could also be seen as an attack, so there's a real uncertainty there that we have to deal with, which makes this topic very challenging. Another thing is the security between the in-body network and the external world. There we have devised a prototype that connects to health databases. We have also recently built a secure aggregator based on trusted execution environment that we heard in several talks, and we have used this to avoid remote compromise and remote denial of sleep attacks. A whole bunch of work, and very successful work, has been done on physical layer attack detection, where we detect attacks based on the physical layer properties of the communication channel, basically trying to prevent that somebody is claiming to be somebody else, but based on the physical layer. And one of the recent work has also been around using backscatter, and they're trying to identify both the entity that generates the carrier and also the tag. Major achievements, we've been doing good jobs to work all the goals. There is in particular, very strong collaboration between the groups that have different backgrounds. We have quite some publications, awards at top conference. We've put a lot of work into phantoms. I will show two of them if time permits. Let me just continue to them. So here's a phantom of a torso of a whole body. You can see that we have the skin, the skin, and the fat and the bone on the sides. We also have used this channel for sensing also. You can see that if you're having two sensors that communicate inside the body and there's a hinder like a tumor that is growing, then this actually makes the communication a little bit worse. Now I come to my last slide because I have almost 0 minutes only left. So this has been successful work. It's really great, exciting multidisciplinary work. this project is also, if you have a secure in-body channel, that enables lots of things, right? We're also talking about, or we're actually doing work on connecting brain-computer interfaces through a secure fat channel to prosthesis, so that you can start kind of, moving your prosthesis. We're also trying to connect these brain-computer interfaces to cars, etc. And if you're interested in these topics, please come and talk to me. And thanks a lot for your attention.
Thank you very much.
Thank you.